In the previous lesson, we were talking about an arithmetic series, and in this lesson, we're going to talk about a geometric series. So the ideas are very much the same. We're going to find the sum of the first n terms of a geometric sequence as opposed to an arithmetic sequence. And just like before, we want to develop a formula that's going to help us find the sum of the first n terms of a geometric sequence. So you know what, let's first say that the sum is represented by s sub n, okay? So it's equal to a plus ar plus ar squared all the way up to ar to the power of n minus 1. So that makes sense because it's the first term, second term, third term, up to the nth term of the geometric series. All right, so what we're going to do is take that equation and we'll multiply both sides by r. Now, why would you do that? Because if you multiply both sides by r, you have this like a staggering effect that's being applied to the terms. Okay, you want to stagger the terms because what we're going to do is take the second equation and subtract it by the first equation. And if you do that, a lot of the terms will cancel each other out, right? ar minus ar squared minus ar squared, ar to the power of n minus 1 minus ar to the power of n minus 1. So all those terms cancel out and you have this left over, okay? And what we're going to do is, because we want to isolate s sub n, right? Because that represents the sum of the first n terms of a geometric series. So factor out s sub n, and then divide both sides by r minus 1. And because you're dividing both sides by r minus 1, we don't want to let r equal 1, because then you can't find the sum. All right, so you know what? Let's apply this formula. So I want to find the sum of the first 10 terms there. So s sub 10 is equal to 20 times negative 3 to the power of 10 minus 1 over negative 3 minus 1. Okay, so 10 terms here. So negative 3 power of 10 minus 1 times 20 divided by negative 4. So we're looking at negative 295,240. All right. So for the next example, we have the first term is 5 and the common ratio is 4. So let's find the sum of the first 10 terms. So 4 to the 10. Okay, wow, huge. 1,747,625. Before we move on to the next example, I just want to quickly mention or explain why the sum of the first 10 terms for 1a is negative. If you think about it, the odd terms of this arithmetic series are positive, and the even terms of this arithmetic series is negative. Now, since you're trying to find the sum of the first 10 terms of this arithmetic series, then the result should be negative, because the 10th term of the arithmetic series is going to, because it's very, very large compared to the value of your other terms. Because that is the case, it's going to dictate the sign of your sum. So the 10th term is negative, so the sum is negative. So if you want, you can find the sum of the first 11 terms, and you'll see that it's positive, because now the 11th term is controlling the sign of the sum. All right, so let's try to do some more problems here. Determine the sum of each geometric series. So you know what? I need to know, based on the formula for the geometric series, I need to know the number of terms I have here. So I'm going to use the general term formula. So 1 over 8 equals a times r. So r in this case is half to the power of n minus 1. So this is 256. 1 over 256 equals 1/2 to the power of n minus 1. Now, because the base of the power is positive, I could use logarithms, or I could just express 1 over 256 as a power with a base of half. You know what? I'm going to use logarithms. And then for the next example, I use the other method. Okay, so this, you can use your calculator, or you can just use your like 2 to the power of what is 256? 2 to the power of 8 So this is 8 equals n minus 1, n is equal to 9. So now that I know there are 9 terms, beautiful. So it's r to the n, half to the 9 over half minus 1. Okay, let's see. Negative 0.5, yes. So it's 511 over 8. Or you can say it's 63.875. Oh yeah, for this one, I definitely can't use logarithms because the common ratio is negative. So it's a good idea to use logarithms here. Alright, so once again, I need to know how many terms I have. So negative 243 is equal to a times r is negative 3 to the power of n minus 1. So negative 243. So negative 243 is negative 3 to the power of 5. And since bases are the same, therefore 5 equals n minus 1, n is 6. There are 6 terms. So let's use the geometric series formula. I know it's tempting just to punch in your calculator and add them up, but please use the geometric series formula. A times r to the n minus 1 all over r minus 1. So because the last term is negative here, the sum will be negative. Negative 182. Okay. Singles tennis tournament has 128 entrants. A player is dropped from the competition after losing one match. Winning players go on to play another match. What is the total number of matches that will be played in this tournament? So in the very first round of this tournament, there's 64 matches. I know you're tempted to say 128 matches, but it's actually 64 because, yeah, you have to play against someone. You don't play against yourself. So there's 64 matches in the first round, and then 32 matches, and then 16, and then all the way up to the championship game. 1 match is played. Okay, so how many matches are there in total? Great question. So A is 64, R is half, but what is N? Well, I know I can find the number of terms in this arithmetic series by using the general term formula. So it's A times R to the power of n minus 1. So 1 over 64. I'm going to use logarithms since the base is positive. So 2 to the power of what? Or half to the power of what is 1 over 64? Or you can ask yourself 2 to the power of what is 64? Let's see, 2 to the power of 6. So n is 7. Okay, there's 7 rounds of tennis. Let's see. Oh, so of course use the geometric series formula. A times r to the power of n, 64. Okay, and then you have 127 matches. All right. Okay, the sum of the first 2 terms in a... For example 4, they say that the sum of the first 2 terms in a geometric series is 12, and the sum of the first 3 terms is 62. So using that information, we can find the first 4 terms of this series. Okay, so if the first term is... Sorry, the sum of the first 2 terms is 12, and the sum of the first 3 terms is 62, you can actually use that information to solve for the 3rd term. Because if I take the sum of the first 3 terms and subtract it by the sum of the first two terms, and that leaves me with the third term. So 62 minus 12, and that's 50. Okay, so I know what the third term is. It must be 50. We need A and R. So you know what? I know that the sum of the first two terms is 12, which means A plus AR is equal to 12. I really want to know what A and R is because I can then answer the question very easily. Unfortunately, there are two variables here. I can't really solve for A, nor can I solve for R. But wait a minute. If the third term is 50, based on what I know about the terms of a geometric series, 50 must be equal to AR squared, right? A to the power of A times R to the power of n minus 1. So since n is 3, then it's R squared. So let's rearrange this, which means A is equal to 50 over R squared. So let A equal 50 over R squared. So instead of A plus AR equals 12, you have 50 over R squared plus 50 over R squared times R equals 12. You can clean this up a little. Oops. Plus 50 over R equals 12. So we're going to multiply both sides by R squared. So we're going to be 50 plus 50R equals 12R squared. What do I see? I see a quadratic equation. So set equal to 0. And then I'm also going to divide both sides by 2, make it easier for me to factor, if it is factorable. Let's see, 5 and plus 5. Oops, no, minus 5 here, plus 5 here, right? No, other way around. I'm being silly. Yep, let's see, negative 30R, there we go. So R is equal to 5, or R is equal to negative 5 over 6. Which means A could be two different numbers. If R equals 5, A equals, let's see, 50 over 5 squared, which is 2. If R equals negative 5 over 6, A will take on a totally different number, which is 72. So therefore, the first four terms are, and we'll do this this one for when A is 2 and R is 5. So it's going to be 2 plus 10 plus 50. And when I see 2, 10, 50, I love it. Because 2 plus 10 gets a 12. And 2, 10, 50 makes a 62. So I don't even care what the fourth term is. But we're going to multiply this by 5, right? So it's 250. Or it could be 72 minus 60, which is beautiful. Gets a 12. Because it's multiplied with negative 5, 6. So you do that again, you get plus 50. And then what's the fourth term? Who cares? But I mean, we're going to find it anyways. But these three terms satisfy both relationships. And I take 50 and multiply by negative 5, 6, negative 125 over 3. So there. Okay, so the terms of the geometric series are either 2, 10, 50, 250, or 72, negative 60, 50, and negative 125 over 3. So that wraps it up for our lessons on sequences and series.